Hello all, as a continuation of my lecture series in transmission and distribution, in the previous videos we have discussed about the mechanical design of a transmission line. So while we design a transmission line, we have to consider many parameters in which we have discussed about what type of conductor which we have to use to design a overhead transmission line. And what are all the possibilities of conductors that can be used? For example, copper, aluminum and steel, and we have seen merits and demerits, and we have concluded that why we people prefer for copper material. So here in this topic, design of transmission line, so in this video we are going to discuss about design of transmission line, choice of transmission voltage and conductor size selection. So in the previous videos we have seen about what type of conductor which we are going to use. But in this video we are going to see about the size selection and choice of transmission voltage. So design of transmission line is there are various technical and economic considerations involved in a design of transmission line. So just like that, we will not be able to design a transmission line. We have to consider many technical and economic considerations. So various parameters to be considered are power handling capacity of a line. So before we design a line, what is the power handling capacity for that particular overhead transmission line has to be known. Distance of transmission. So from where to where we are going to transfer electrical power. So what is the distance about? So either it is a short distance or a long distance. So that we have to know. And at last, road voltage regulation and efficiency are specified. So efficiency is very important. That is how much percentage of power that we are capable or able to transfer from one place to another. So before we go into the design of transmission line, we have to consider three parameters: power handling capacity, distance of transmission, and voltage regulation and efficiency. So this is very important. Coming to next parameters. So what are all the parameters? Is line voltage, size of phase conductors, span, what type of spacing and configuration of conductors, number of insulators, clearance values, and size of earth wire are included in the design. So before we design, we have to consider all these parameters: line voltage, size of phase conductors, span, spacing and configuration of conductors, number of insulators, clearance values, and size of earth wires are included in the design. With the help of the above mentioned parameters, the voltage regulation and efficiency of the transmission line can be determined. So by knowing all the values which we mentioned earlier, we can determine the voltage regulation and efficiency of the transmission line. A revised design is made if any of these quantities are not lying within the specified limits. So the above mentioned values is not lying between the specified limits, then the design has to be revised. Okay. So coming to choice of transmission voltage. So the line voltage greatly affects the performance of the line and its cost. So based on the voltage, the thickness of wire varies. So the thickness of wire is increased, then the cost of the transmission erection will also be increased. To achieve the optimum operating transmission voltage, we have a formula. So where V is the operating line voltage and D is the distance that we have to know, and P is power handled in terms of kilowatts. So this formula is to be used in order to choose the transmission voltage. So as we have discussed, using the above formula, we can determine the voltage, transmission line voltage. So the detailed analysis has to be made on results from the formula. So we have to make many possibilities, and from the results from the formula, we can decide whether if the value is between 300 to 765 kilowatt, then it should be EHV line, that is extra high voltage transmission line. And if the voltage varies greater than 765, then it will be ultra high voltage. So based on this voltage value only, we may have the size of conductor. By considering various technical and economic aspects, it is possible to obtain the most economic voltage. So we have to check for many possibilities before we design a transmission line. Next one is conductor size selection. So the size of the conductor should be properly selected during design, as about 30 to 45% of total cost in the line is involved in the cost of the conductor. Yes, for example, if you are going to choose copper wire, the wire is the main part of our transmission. Yes, so for either for a long transmission or a short transmission, the choice of conductor is very important. So it plays the total cost of 30 to 45% in our total budget. The size of the conductor decides cost of towers and foundations. So first one is conductor value, and next one is cost of tower and foundations have the next highest value. The losses in the line depends on size of the conductor. Yes. Then ACSR conductors are used, which are available in various sizes. So this type of conductor yesterday we have seen in our video. The line should carry the rated current continuously without excessive temperature rise for given conductor size. So due to temperature, the sag associated with the line and tensile strength is affected. The sag is, so the line will not be straight, it will be a U-shaped structure. That is what we call it as sag. And due to high temperatures, annealing of conductor takes place, and the typical value for copper and aluminum is around 100 degrees Celsius. Then the operating temperature of the line must be well below 75 degrees. And the copper losses, I square R losses we have to consider. And based on the conductor heating and heat dissipation, temperature of conductor is increased. So this is the conductor size selection which we have to take in account. So for steady state temperature, that is the losses formula is the loss of heat due to convection and loss of heat due to radiation. So we have to consider these two along with the surface area of the conductor. So this is the formula for steady temperature. Coming to heat loss due to convection. So what is the heat loss that is due to convection is, it depends on the velocity, conductor diameter and temperature difference between the conductor. So this is convection. And coming to radiation, it is because of conductor temperature, surrounding temperature and relative emissivity of the surface. So in this video we have discussed about the choice of conductor selection and what are all the types of losses may happen in the conductor, convection and radiation. So coming to assessment, which primary parameter is uniformly distributed along the length of the conductor is resistance is the primary parameter. So because that is uniformly distributed along the length of the conductor. So it depends on the cross section area and the length of the conductor. So the resistance is very important. And the leakage current in the transmission line is referred to as conductance. The dielectrics or insulators of the open wire line may not be perfect. So, and a leakage current will flow. This leakage conductance exists between the conductors. So, thank you. We will see in the next video.